So you've seen my truck. The question is, you've probably not seen when I'm working. So in Friday Harbor, I work for San Juan EMS. And San Juan EMS, right out by the airport, 4 ambulances and a handful of paramedic vehicles and things like that. So as an emergency vehicle technician, my responsibility is literally from the tires to the light bar. Every single bit of those aid rigs are maintained out of my very messy truck at the moment. Sorry about my truck being so messy. I'm a kind of a meticulous guy, and it's embarrassing that my truck is so messy. But an emergency vehicle needs to always be able to respond. We maintain to a completely different standard than a normal over-the-road vehicle. And so I'm able to, with my truck, come right up to the vehicle and maintain it where it sits, give everything that it needs. Um, I originally was working for Orcus Fire through the 90s and early 2000s, but then I started my own business in 2006, doing what I did for them everywhere else. So I work for San Juan EMS, but really I maintain close to 100 emergency vehicles throughout San Juan, Skagit Island, and King County. This is one of the fire stations I work at. This is the working end. This is down in Woodinville Fire. You notice those cabs look identical. However, those vehicles are very much not identical. So I'm responsible for all of these vehicles, all emergency vehicles for Woodinville Fire. This is a brand new ambulance. And we're really happy to be able to bring these on board. We were able to pick up 3 of them to replace older Ford ambulances. And these are the latest and greatest, most modern vehicle aid rigs, ambulances on the road. So notice that there's a computer right in the middle of the vehicle. The vehicle is run through that computer monitor right there. So everything is accessed right through the computer. So we turn on the lights. Everything is done on what we call the CAN bus, so computerized. So lots and lots of lights, tons of lights, all LED, really kind of amazing and awesome. But as an emergency vehicle technician, I am responsible for 100% of this vehicle. The operational effectiveness, the fact that I need to keep it running. We're not allowed to have a vehicle not start or not run. Notice that I've got a computer system, a camera system here. That's the left-hand side is the back camera, but look down on the right-hand side. On the right-hand side, you can see a downward-looking camera. That's the aid rig in the middle and the roll-up door in front of us. We are able to simulate a 360 view around our aid vehicle with all the cameras that are on board this aid rig. So the technology of this vehicle is pretty remarkable, really, really amazing. Technology, well, look at those back windows, how you can't see through them. You're unable to see it. I open the door and you can see through it. You can see through the window, but when I close the door, you can't see through it anymore. That's electronic privacy glass. So the technology, again, on these vehicles blows the mind. I'm able to make the windows opaque electronically. So that's the EMT end, the patient side of the aid vehicle. And we'll hop up inside. In the day of COVID, it's a little bit different inside here, but no worries. We just won't touch anything. That's why we're virtual. But brand new. Notice the harnesses, the 4-point harnesses. Notice that seat is also forward facing. When I designed up this aid rig, it was really important for me that the EMT would be forward facing. In accidents, it's proven and shown that a forward-facing occupant has a much higher survivability. This is my area, and this is the brain of the aid rig. And so this is just one of the compartments there. This is where the electrical system is run. The gray boxes in the back here, 2 of them, and then 2 more on our left are the computers. These are computers that are programmed to keep this vehicle running. When you turn on a light, it's not a switch that has contacts that allows electrons to travel to a filament. It's actually a computer. That is a wire schematic. That's a pinout wire schematic for how the computers are basically pinned out, set up, wired. So hopping out of our aid rig, let's see here. Where do I go with this video? Amazing. 3 brand new aid rigs in service not too long ago. Next vehicle over is a ladder truck. So cabs are the same. However, this truck is built up as a tractor trailer. So notice the steer axle on the left, 2 drive axles on the right. That's the tractor. And then the trailer is back there, the trailer holding the big ladder with another axle all the way to the rear. So this truck, this is a fire truck, not a fire engine. So a fire truck has a ladder. And so I'll go ahead and turn it on here, and I'm not playing the audio because it's incredibly noisy. Sorry about that, all the alarms and all the whiz bangs, but the dashboard comes alive. But look that there's a computer right next to us, a computer monitor, just like the aid rigs. And that computer monitor is giving us a complete status of everything that's on the vehicle. Notice the tires there, the green boxes are all our tires. And the red is me sitting in a seat without a seat belt. It's monitoring all the safety of this vehicle. So fuel levels, DEF, diesel exhaust fluid levels. I can access a ton of different areas. I can go into each individual tire and know exactly what the tire pressure is through the computer system. The computer is monitoring my tire pressure. It's also monitoring the ladder. So when the firefighter is driving down the road wanting to set up the ladder, it's important that grade, slope, and jackknife are considered for the stability of the ladder. So the vehicle is keeping track of all of these things simultaneously all the time, so that the driver can see that they're optimally spotted, set up, so that they can fly the ladder to wherever they need to go. So this is real time where the ladder is. Currently it's at -3 degrees sitting in the truck. It has a downward tilt to it. The current load chart, the computer is telling us we can put 750 pounds on the end of this ladder as it sits right now. So a ton of different things that this computer can access into. As an EVT, diagnostics is critical. Really, technicians today, I need to be able to go into this computer, run some tests, take a look at it, and make sure that this vehicle is perfectly healthy and ready to respond. We're not allowed to allow a vehicle to go to a failure. We have to be able to anticipate it, see it, test it, and address it before it actually goes to failure. So it's our world has completely changed. When I started as a fire mechanic, there was one computer and it was in the office of the fire station. This vehicle itself has over 45 computers on board. 45 computers. Okay, same cab, vehicle next door. On the outside, it looks the same, but when you look inside this vehicle, this is a fire engine built up with a single drive axle. So this has a pump and carries water. Fire engine. The fire truck is behind us. We hop up in this cab and notice how the dashboard is different. So this has old school gauges. So and there's no computer sitting next to us. It's got toggle switches. So hardwired. This is an old school electrical system. So it's got electrical conductors, copper conductors that run from a switch to a filament of a light or whatever it is. It is not run by computers. Okay, so brand new ladder truck. It's only about a year old. This ladder truck has a fire pump, which is right there, which is pretty awesome. Not all ladder trucks have a fire pump. Because it has a fire pump, and believe it or not, inside there is a water tank with hundreds of gallons of water. This technically is called a quint because this truck also has a pump and water. But the turntable and a 107-foot long ladder, an incredibly long ladder to reach high up in buildings or way off in hard to get to places. Very, very beautiful ladder. So this turns into kind of like a sales pitch to become a firefighter. But back here is another driver, the driver for the rear axle. So there's the steering wheel, and I'll show you in the video. That's the driver's seat, the rear driver. So this vehicle has two drivers. So the rear driver is steering that axle there. They don't have an accelerator pedal or a brake. All they can do is steer that tire back there. But this 63-foot long vehicle can hang a U-turn in less space than the aid rig over there. Yes, you heard that correctly. I can hang a U-turn in this ladder truck gracefully in places that you can't hang a U-turn in the aid rig. So fascinating, unbelievable. The maneuverability of a tillered ladder truck is just unbelievable. Okay, so Woodinville, this is where I work, and this is a reserve engine, a second out engine, and you can kind of see where, oh yeah, this is kind of where I'm working currently. I've got a problem with this fire engine, and that component right there, it pains me to see it, failed. And I'm replacing that valve, but I had to remove the pump panel in order to make that happen. And that is a very, very time-consuming task. If you look at every single connector, all of the connectors, all the components, the hoses, everything that I had to disconnect, it took me hours and hours to get the panel off to be able to access that valve. So I'm not too happy with the designers of this fire engine that made it so difficult to pull that panel and then put a very fragile valve behind it, but we won't talk about that. That's okay. Being an EVT isn't exactly an easy thing. So this is what a pump panel looks like when it's still on. So you can now kind of visualize what all I had to take off in order to be able to get in there and do that. But so that's a quick kind of tour, a virtual tour in the time of COVID of where I work. So this is just one of the fire stations I work at. I work at a dozen different fire stations, again, responsible for almost 100 emergency vehicles. So it's unique in the fire service that I go to the emergency vehicle. In other fire departments, you know, you might take a vehicle to a remote shop or something like that. This is one of my current projects. I'm working on a brush truck. This is an engine that responds to wildland fires. It has a pump in the back, a big old black water tank right there. And working in the wildland on brush fire, forest fires, we're hard on our brakes. So this vehicle is getting new brakes. And before fire season, we're putting new brakes on it. There's new brake pads and a rotor, and I'm in the process of repairing those brakes. So the project I did before this was I installed a new inverter charger. That's the white box right there. See the yellow outlets there? That looks like house current. That box converts the battery power under the hood to AC power, so you can plug things in there that would be on normal house current. So house current being 120 volts. So think coffee pot, microwave, all that. And you might ask yourself, wait, what? Why do you have that power out there? Well, this vehicle will roll out for 2 weeks at a time, and the firefighters will live out of this vehicle. And in this time, especially this year, I wanted to improve their ability to keep themselves fed well. And so I wanted them to be able to throw a microwave in there and go to Walmart or wherever it was, and Fred Meyer, and get a light microwave or a coffee pot or something like that, so they can keep themselves fed for the weeks that they're gone. We might not have big fire camps this year in the time of COVID. But so you can see that I'm working here on the brakes, and we know that I have that funny white truck. Well, if you follow the yellow hose from the project back from here, it'll lead you back to my truck. So in many shops, the technician has a roll around box where they roll the box of tools up to the project, and they work on whatever it is. Well, I also have a toolbox. It just happens to be mounted on a service truck. So my service truck, I drive it to wherever I'm working. You know, wildland fire, I will literally drive around camp to all the different vehicles as I work on them. But on board, I have almost everything I need to fully inspect, maintain, and repair emergency vehicles, pretty much wherever I'm at. Specific stuff like with brakes, I'll have brake fluid, but if I need to put new brake pads and a rotor onto a vehicle, I have to bring those in. But all the normal maintenance items, all the lights and electrical connectors, liquids, things like that, are all kept in my service truck. And I will get into more about the service truck in other videos, but basically that's what I do. So I'm not unique altogether. Service trucks are a pretty common thing. If you look on I-5, you will see a service truck driving down the road with hose reels and a crane and all that. This is kind of how our industry works. So going out to job sites or broken down semi trucks on the side of the road, we use service trucks. And my service truck has what I need, has the liquids, has the tools to try and get the job done. So that is a very quick tour of kind of where I work. And yeah, that's what I know. So Mickey, can you tell me if, let's see here. Let's see if I can get out of this. Can you tell me?
Having done a couple of overnights at a couple of state mobs.
Yeah, yeah.
We had a one strike team leader who had a coffee pot in their command rig, and that was very much appreciated by the entire group.
Yeah, exactly. Yeah, so let's see here. I'm gonna see if I can share some more stuff for you. Did the video come across as good video?
It was a little jerky. There was no sound, which is probably good. So since the sound on the video would have obscured your talking, so
you could hear my voice.
It was a little bit jerky, but otherwise it was fine.
All right, sorry about that. So that's good. All right, so I was a little concerned that we wouldn't be able to see it. I'm going to go ahead and see if I can.
Good question. As you're working on that, you said you were to help design the ambulances. So, were you working with the department to like what level of design were you talking about there?
Yeah. As a master emergency vehicle technician, one of my exams that I have to pass is the design of fire apparatus. So a firefighter knows how to use a fire engine. A fire chief knows how to write a budget to buy a fire engine, but the actually technical designing of the fire engine is incredibly technical. And so it is the EVT who knows how it's put together. So if you want a Ford pickup truck, you go to the Ford dealer and you have a couple of options. If you want a fire engine, it's all options. That's all there is to it. The specification for any emergency vehicle is about 100 pages long, 100, 200 pages long. So I truly designed up, I worked very closely with a committee of firefighters who are the users, and I helped them to paint the picture of exactly the vehicle they wanted. Now, I have a lot of opinion and desire to have a fantastically put together machine. And so when it comes to tires, rims, axles, frames, literally the frame itself, how many frame channels you have, the electrical system, everything about the diesel engine, the transmission, the braking systems, the electronic systems, even the lighting packages, how you put together the lights, which lights you use, all have an impact on the vehicle. And so since my world completely revolves around an emergency vehicle, I'm really there to help support the firefighters to get the vehicle they want. And yes, I am a professional designer of emergency vehicles through my um, testing and exams and certifications. I'm the guy that helps design it. There's a salesperson who wants us to spend as much money as possible. I'm the EVT who wants the most functional vehicle possible. And the firefighters are the ones who want the vehicle that will really do the job for them. So, yeah, I contract now at this point. It's not a starting position, but now after decades of doing this, fire departments will hire me to come and be that person on their committee to help their firefighters really get the vehicle that they need or want. Deciding which alternator to use or which diesel engine to use really needs, those decisions need to happen from a technician, not from an operator. How's that?
Well, thank you.
Yeah, yeah. So you asked me, Mickey, to highlight some specific tools that I use, and I had a little fun with it. And so I've got a couple more videos I'd like to kind of show you. Am I sharing that video? Can you see my screen there?
Right now we see the screen, but it's just the directory.
Let's see here. You're not seeing this video.
No.
All right. I will jump backwards here. And I'm not sure what that is. I'm going to go back to here, meeting controls. I'm going to stop sharing that. Let's see here. Two seconds. I need that.
It's back to the directory.
Back to the directory.
There it is.
You got it. All right. So you asked me to show the tools I use. Well, here's a virtual tour of my office. Well, technically, since I work on the road, my office many times is the cab of my truck. And so I'll show you here. I'm working on the brakes on that brush truck, right? And so I want you to see, welcome to my office. It's actually the cab of my truck. And I wanted to show you that one tool I use, I'm a certified technician. I look at the instructions every time. I read instructions every time. Yeah. So we don't just fudge it. I go right to the Motorcraft website for brakes. This is the brakes of this Ford pickup truck. How many brakes have I done? Well, tons. I go to the Motorcraft website, and every single time I do brakes, and I look up the very specific vehicle that I'm working on. Look at the VIN number right there. It's a 2008 F550. There's the VIN number. I don't know if they've made changes at all or anything like that. Every single time I go into their website. Now, it's not like I don't know how to do it. What I don't know is what are the torque specs I need to use to tighten all those fasteners. Every single fastener, for the most part, that I will tighten in this project is in there, and I write it on my glove. I take notes of what those torque specs are. And it's critically important in order to do the job correctly to torque all of the fasteners into absolutely the exactly correct torque spec. So there's my torque wrench, really expensive. It's $600, $700. It's an electronic torque wrench. Lights go on, it makes noises, it actually rattles to tell me. So 295 foot-pounds for the anchor plate. That's a lot of torque. 295 pounds at a 1 foot bar. That big old bolt right there, that's what holds the caliper onto the vehicle. 130 pounds for the hub nuts. So that's those right here. Those bolts hold that hub onto the rotor, onto the vehicle. That's what holds your wheel on, 130. And then the small bolts right here are what actually hold the caliper on, and they are 46 foot-pounds. So every single bolt is tightened according to what the torque spec says in the Ford manual. So it's not cool to try and work on something if you don't have the instructions, because you got to know exactly what to do. So that's one tool. So it's a computer, and it's the instructions, and it's a calibrated, expensive torque wrench. But I've got other tools I use also. So oh my gosh, that caliper was the rotor was stuck on that hub so incredibly bad. I was pounding on it. I couldn't get it off. So I turned around. Behind me, there's that ladder truck, right? I'm working on this brush truck over here. I've got a stuck rotor down there, and I can't get the hub off. And so I turned around and I opened up the compartment behind me on the ladder truck. And oh, guess what? Yeah, the jaws of life, fire service. Yeah, okay. So this is the cutters. That's a telescoping ram. The tool that's supposed to be sitting right there, I have borrowed. I've borrowed because I'm a fire engine mechanic and I have available to me the jaws of life. So when something's really stuck, like a hub on a rotor, I take out the jaws of life, which is that thing right there, and I go ahead and just separate the hub off of the rotor. It was just rusted on forever and ever sitting there. So I just put those little thingies in there, and I just kind of opened it up. I spread it. I pulled the hub away from the rotor over here, and I made a separation, and I was able to get it off so I can put a new rotor on. I wanted to put a new rotor on there so it's nice, fresh, and clean. And so I cheated. It only took me 60 seconds, and I was able to pop it off. So, okay, so I do have special tools that all shops, every other shop doesn't have this because they're extremely expensive, the jaws of life. But you know, I get to cheat because I'm a fire engine mechanic, and I've got the tool, so why not use it? All right. What else do I have? Oh, okay. So here's a note that I wanted to point out. Okay, I am 6 feet tall. I am big. I am strong. But really, no one can actually put 295 foot-pounds of torque onto a bolt. Just let's be perfectly clear about that. My torque wrench only goes up to 250. So the other wrench that's attached to the torque wrench is a torque multiplier. So it's a 4-to-1 torque multiplier. So the input that I have to put into this system in order to get 295 is actually 82 foot-pounds. So anybody can go ahead and lift that wrench to 82 foot-pounds. So it's like the input of our human energy into it is closer to maybe 50 pounds or something like that. You still have to have strength, but you don't have to be an animal to be a mechanic. We try to work, smarter. We try to have the right tools. And my last little video I have here for us is, again, here's the fire station. I wanted to show you the bread and butter I do. I don't do a phenomenal amount of repair. Yes, of course, I am in the middle of that pump panel, replacing a bad valve. There's the panel still on. This video was taken before I pulled it off. This is just a normal service for a fire engine. So regular service, preventative maintenance is my bread and butter. For my vehicles. There's a creeper, an oil pan. I change out all the liquids and all the filters on a regular basis, change out the brakes, fluid on hydraulic vehicle. There's a fuel filter down there, batteries, whatever it is. Regular maintenance is our bread and butter. So we maintain it so we don't have to repair it. And this is what we do. So as a young person coming into the industry, realize that when you get through your 2-year training, you will look at that engine and go, yeah, I know that. That's a DD13. That's a, and then you'll look down there and go, what in the world is that? That's a suspension that you'll only find on a $750,000 fire engine. But that's a wishbone suspension that looks more like a car than a truck. But there's my truck and all that. But so that's what I know. All right. So that is the basics of what I do. And I have a little bit of Forest Service stuff that I can share, Mickey. Another little presentation of the work that I do for the Forest Service, just to explain to people that you can take really weird directions, and if it excites you.
I'd probably have fun with it, but we are pretty close to the hour, and I think
Yeah.
I think I told you I'd only take up 45 minutes of your time. So
Yeah,
um,
yeah, 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 yeah.
yeah, so it's up to you if you're free to show them. Since we're putting this all online, I can split things up into sort of bite-sized chunks, and
Yeah, 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 no
I'm
doubt.
happy to keep going.
Yeah, so I'll make it really, really super quick. But because I've been a firefighter for a long time, and I was tired of digging fire trail and all that, I realized I could actually um, be hired out as what they call a mech 2. So a mechanic. I work on fire engines for the Forest Service on our largest fires. So I have a contract with the Forest Service, and when the world catches on fire, they send me. And I do what I do normally in fire stations, I do for the Forest Service in a hayfield somewhere. And it's really lots of fun. I get calls like, "Hey, Paul, in Zulu, there is a buggy. This thing's called a buggy. When we started it up, it caught fire, and every time we turn the ignition on, it catches fire inside the cab. Oh, and by the way, the fire is coming towards that vehicle, and we got to get it out of there really quick, or else the fire's going to burn it up." And so here I am in the cab. There's my truck, and I see this big cloud of smoke just over the horizon. And so I know that I don't have a lot of time, but I've got to get this vehicle running. And so I listen to the radio, do all my normal safety stuff, and I hear them say, "Oh yeah, fire's burning over these dozers," and so they're running away. And I think, okay, no sweat, the fire's not near me. And then all of a sudden, the dozers drive in front of my truck, and I go, "Oh my God, that's 2 minutes away." And so the fire is only 15 minutes from us, from right here, and it's so sometimes it's kind of exciting, but I was able to fix the vehicle, find a driver to drive it away. I was able to save a very expensive vehicle. But this is me out on a wildland fire, and so my office is a blue tarp, and you break it, you bring it to me, or I go to it and I take care of it. um, it doesn't really matter. I go with a trailer, so I have an office, and this is the Chelan Reach Fire. But ultimately, on that day, DC-10 came and pretty much landed in the middle of Chelan. That's it pulling up. But this whole area burned over shortly after we left. I work with some real heroes on the wildland fire. It's amazing the people you work with. Um, but sometimes the fire comes right down on top of you, and but it's always safe, it's always good. We also always have the keys in the ignition of our vehicles no matter what. And but sometimes not all vehicles survive it. This very expensive fire engine in that fire caught fire. The air filter caught fire, and it was a very, very bad day. But sometimes firefighters are mean to their vehicles, and this firefighter didn't know that you're not supposed to keep your foot on the brakes all the time, and they literally set their brakes on fire. But being who we are, we're able to fix almost anything except helicopters. So I'm not allowed to work on helicopters, but I'm allowed to lend my tools to helicopter mechanics and when they need to fix something. So it's just one of the weird, funny things I do. Um, uh, as I go out there, I replace radiators. I do whatever it is that needs to happen to fix vehicles wherever it is. In the middle of a hayfield, I can go ahead and install a new radiator. Yeah, but living in fire camps is what I do in the summertime in Washington. So there you go. Oh, I gypped you on one last picture, but sometimes I get to look after. Oh, it ended. I get to look after my local firefighters. So on a wildland fire, I was out there responsible for one of the Orcus fire engines. So that was a lot of fun seeing family out there on one of our big fires. Yeah, so there you go, Mickey. How'd I do? Did I hit the target?
That's great. Thank you so much for coming and showing us all that. And I had a really good time.
Yeah,
So,
fantastic. So the note to self to anybody who happens to watch this is it's really up to them. It's a lot of investment of their time and energy to go ahead and get the training necessary to be effective at a job they're seeking. And the fun part is that they will be compensated every single hour that they're working. If they do that work, if they become a technician, they will get paid really well. And today, being able to receive a starting pay $100,000 as a technician, as a mechanic, is truly awesome. I think it's great. That's a reason. That's a really good amount of money for a person who's starting out in a career.
also a pretty big responsibility too, though. So,
Yeah, it is a lot of responsibility, no doubt. Well, thanks for the opportunity, Mickey. I really appreciate it.
well, thank you so much for coming, and we'll get this up online. And may take me a little bit to edit, but I'll get it
Yeah,
up
yeah,
online.
yeah, yeah. Go, man, go. All righty.
Thank you.
All right, thanks. Bye-bye.